Hello everyone. Hi everyone. My name is Madhushri. I am a student of VIT Chennai, Triple E third year. I'm doing CSE minor. I have a subject called Computer Architecture and Organization. So I have got a digital assignment to do uh, to do a project on NAND2TETRIS. What is NAND2TETRIS? I will tell you first. NAND2TETRIS is a hardware simulator. Like it's a hardware computer. We build a computer, the hardware portion of it. So the hardware portion of it mainly consists of many gates, like legit many gates and different types of gates and or XOR, mux, demux, any combinational circuits, half adder, full adder, everything. So now I will tell you how to use NAND gate. Why do we use NAND gate? Basically because it's a universal gate. Any gates can be derived from a NAND gate basically. So we'll start. I'll present one. I'll share the screen so that you guys can see. And yes, so we are on. I'll tell you first is like, I'll go back. First, let me go to the NAND to Tetris. Hmm. This is the NAND2TETRIS.org website. So you go to the software and click software so that you can download the hardware simulator where you will actually be working on the gates. You code the gates so that you get the output and you can verify that whatever you have coded is correct. So we basically download this NAND2TETRIS software suite, which consists of projects and tools. So you'll get a zip folder. So the zip folder already consists of hardware simulator, but before um, you know using hardware simulator in your system, you should have Java already installed in your computer. Otherwise, hardware simulator doesn't work. So now the hardware simulator, I'll just open this. This is the hardware simulator that we get. So first, we'll go here, this black color thing, load chip. So we'll go to the load chip and we'll go to the project one. We are doing project one first. And first, let us start with AND gate. We'll load the chip. Okay, so we have loaded the chip. I have coded this, but you cannot code here directly in the HDL part. You have to use it as a notepad. Like you have to open the file in a text editor, edit the file. The first input output is already provided. The path section we need to complete and we need to actually complete the coding. So AND gate, we are using NAND gate because it's universal gate and we can do it like we can actually work it out. Now next we'll load a script. We need to check whether this code is correct or not. So we basically load the chip, 1 minute, and .txt file you'll get. So we load the script here. After loading the script, we will perform this single step execution. First we'll go. Now we are giving input as 0 and A as 0 and B as 0. So let's go through it and we get the output also as 0. AND gate, you guys know 0, 0, 0. Only when all the inputs are 1, we get the output as 1. So 1, 0, again 0. Last we are getting 1. So I'll just explain you the code here. Like what did I do in the coding part? The output is correct. We are verifying it. That's perfectly fine. I'll just tell you here A is equal to first line I have written NAND A is equal to A. So consider that I am taking A is equal to 1. Then B is equal to B. Like the input I am giving 1. Then output I am giving as C. Like if you give 1 and 1 in NAND gate, what is the output that you're getting? 1 into 1 is 1, but this is NAND, just the opposite complement. That will become 0. Cool? Now out is equal to 0. That is C. Okay, just a minute. That is equal to C. Now A is equal to C, the next step. So A is equal to 0, B is equal to C again, B is equal to 0 again. Now out is equal to out. You're passing this inputs through NAND gate. So 0 into 0 will become 1. If we pass this through AND gate, we'll get 0. But we are passing here into NAND gate. So we get the complement. So we are getting it as 1. Is the output right? 1 into 1 is 1. So I think you guys have understood. I just took one case, like if A is equal to 1, B is equal to 1, what do we get as the output? So we get it as 1. If you solve it in every input like 0, 1, 1, 0, you'll get the answer. So yes, now I'll just tell you, if I compare, like here, I've loaded the test script to check whether it's correct or not. Now if I compare, see, I'm getting the right result, right? Like this should be my result: 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. I have shown you at the output pins, we are getting the exact thing. That means this program is correct. So we are done with our first program. So let's go to the second one. Let's do add 16. I'll load the chip again as usual. In add 16, we basically again get the same thing, like the AND operation is only performed. So here, first I showed you we can visualize the output, like we can verify the output by two methods. We can load the script, test script and check it out. We can also manually take inputs and we can get the output. So if I manually enter it, like 101, if I do this, and if I get 101 or something like that, and this is the evaluation part, you need to click this to get the output. So you're getting 101. It actually checks bitwise and does the AND. 1 into 1 is 1, 0 into 0 is 0, 1 into 1 is 1. So the program is correct. Whatever coding I have done, it is actually correct because the output is correct. Hence, next I'll check the compare part, whether the compare is given or not. Oh, we cannot do the compare until and unless we load the test script. Okay, so we need to do that. But I don't think we need to do that because we are getting the answer. So that is fine. If you do any one of the options, that is more than fine, I feel. Next, I'll go to the coding part, what I have done. Here, the coding part is like, uh, yeah, we have two inputs, A and B, 16 bits and 16, so 16 bits each. Then we'll get the output. Here, I have passed every single output through AND gate and you get the output. So like every bit is passed through AND gate and you get the output. That is what AND 16 basically does. Next we'll go through, first we'll complete the easiest one and then only we'll go to the combinational circuits. We'll go to NOT. We'll load the chip. So here I'll again tell you. Now this one, what was the first one? First one I explained was and okay. Now next we'll go to not. Okay, I'll explain you the program first. First we are taking as in. Sorry, I'm really sorry. Yeah, in like they have given the input as in and the output should be out. So we are again using NAND gate because it's a universal gate. Any gate can be made up through NAND. So A is equal to N. So suppose A is equal to 1. A is equal to 1. Okay, like we are taking in as 1. B is also equal to 1. Now out is equal to out. We are passing through NAND gate. A and B is 1, 1. If we would have passed through AND gate, 1 into 1 is 1. But NAND is AND's complement. So 1's complement is 0. We are getting the output as 0. So if we put the input as 1, we are getting the output as 0. Vice versa. Another case, let's consider A is equal to 0. And again, I'm doing B is equal to 0. Sorry, B is equal to 0. Out is again, we're passing through 0 into 0 is 0, but zero's complement is 1. So basically, what does not do? If you give 1, it will become 0. And if you give 0, it will become 1. So yes, let's check it out. I'm doing normal. 1, enter, evaluate. We are getting 0. Change it to 0. We are getting 1. I'll just tell you that if you do the same thing, like if you load the text fixture code, like testing code, and check, it will be the same thing again. Single step execution. You're giving input as 0. What will be your output? 1. You check. And if you give input as 1, output is 0. So basically, if we manually enter the inputs, we get the same output. And if we load the test scripture file, which is already given in that software, like which we downloaded in the zip folder, we'll get the same output. We are getting the same output. That means our thing is correct. See, 101, 1 becomes, sorry, 0 becomes 1 and 1 becomes 0. So I think you guys are fine with and 16, not till now. Now we'll go for not 16. In not 16, we basically do the complement of each bit. We take each bit. I'll manually enter the thing so that you guys can actually understand. Okay, just check. Just give the ones complement. Like it just gives the negation of whatever number you put, it just gives the negation of it. Like 5 becomes minus 5. So I will just go to my notepad again. Not 16. So you take any number. Suppose you take 0, 1, 1, sorry, 0, 1, 0, 1. Okay. This is equal to 5. I'm taking it as a binary number, but 5 is a like decimal number is 5, and if I convert it to binary, it becomes 0, 1, 0, 1. Now you do one's complement. 1, 0, 1, 0. Is it okay? Fine? Okay. So then you add 1 to it. Sorry. Add 1 to it. How much do you get? 1, 0, 1, 1. Is it fine? 8 plus 2, 10 plus 11. It's fine, right? I mean, it just does the negation of it. Whatever you give, like if you give 5, you'll get minus 5. It's like that. Are you guys understanding? Hopefully. Like if you know one's complement, two's complements, it's basically that. Not 16 gives you that value. Right? It just whatever binary values you provide, it just gives you the negation of it. For example, I'll just load the text fixture so that you can understand it better properly. Okay, so you're getting 0, 0, 0, 0, and you're getting the output is minus 1. Next we'll go, you're giving minus 1, you're getting 0. Okay, see, minus 21846, you're getting the output as 21845. Like anything you give, you just get the positive value. 15555, just give the negation and just add 1. Did you get it? Hopefully yes. Like it's just the two's complements. Next we'll go to We'll start with odd. Okay, I'll explain you the code what I had done actually basically. NAND here states that A is equal to A. I'm giving two inputs A and B, we are getting one output. So A is equal to consider 0. I have only taken till now 0 and 1. Sorry, 0, 0 or 1, 1. So let's try something different. Why not different? Let's take the case of 0 and 1. Like A is equal to 0 and B is equal to 1. We are giving two other inputs. But first line, just check A is equal to A. And B is also as equal to A only. So 0 only. So out will become what? 0 into 0 is 0. Complement 1. Fine. And that we are storing it in C. Next, we'll go to A equal to B. B is how much? 1. Next, B is equal to B. How much B is? 1. Next, 1. Yeah, sorry. Output is equal to 1 into 1 is 1. Complement 0. This is equal to B. Fine. So A is equal to C. Next line. C is 1. B is how much? B is equal to B. B is 0 for my case. Next, you'll get out 1 into 0 is 1 into 0 is 0. Complement 1. And that we are storing as an output. So basically, if you give 0 and what was the output, guys? I think 1, right? Huh. So you're getting 1. See? Like 0 plus 1. 0 and all is 1. So yeah. So this is the main agenda. So I've explained you the code, I guess. Now we'll load the text fixture code. That will be better, I feel. Let's load it out. Um, just check 000, 000, 111, 101, 111. So this proves that our coding actually is correct because we are getting the right answer. Next, we'll go to sorry, R8. R8. What do we do in R8? There is only one input and there are 8 bits. Like if any, you give any number. Suppose I give any number here, 101010, any number. Will it take it? No, it doesn't take such a big number. So one minute. If I give 12, will it take that? Yeah, it takes. If I evaluate it, I get 1. Why? Because if you give any number which is not 0, it will give you 1. Because there is only case like if you give a 0, if your input is 0 and 0, then only you'll get your output as 0, right? Otherwise, in all the case, any input you give, you'll always get the answer as 1. So just check if I get 0, it will give me 0 for sure. Do it anything. Like if you give it 13 or you want to give 8, you get 1. Everything is 1. So here basically they have given only one input and which is of 8 bits. We take each bit and check that like do OR of the 0th bit and first bit. In the first line if you see 0th bit and first bit we do OR addition, normal addition, and we store it in A. And then next line, we take that normal addition value E and B is equal to inner 2, like whatever is in the second bit. We take that and we do addition and store it in B. Next again we load that in A and we do the that or we OR that with the third bit. This is how the program runs actually. So I hope I have been very clear and very, you guys have understood it. I really hope that. Just a minute, I'll cross check it with the load script or it. 0, 0, 0. You give any number, you'll get 1. Any number, any, you'll get 1. See, it's correct. That means I compare. See, any number you give, you'll get 1. If you give 0, you get 0. Next, we'll go with or 16. 1 minute. Sorry, we'll first complete XOR and then we'll go to or 16. That will be better, I guess. Yes, in XOR, I give XOR 0, 0 should be 0. 0, 0, 0. 1 minute. What is happening? I mean, just a minute. Yep. 0, 0. Okay. 0, 1, 1. I don't know why was it not taking 0, 0. That's fine. 0, 0, 0. 0, 1, 1. I'll check with 1, 1, 0. Fine. 1. Like if any one of the input is 1, you'll get 1. And if both the inputs are zeros or if both the inputs are 1, you'll get a 0. I'll explain you the code without any further delay. Okay, so and the code the thing is that 1 minute. Okay, let's start with XOR. And XOR, yes, not n is equal to a. Suppose I take a is equal to 1. N is equal to 1 and out is equal to NA. So out is equal to basically 0 because we are passing it through NOT gate. So it will give you the other thing. Now not in is equal to b, in is equal to 0. So I'm taking a is equal to 0 and b is equal to, sorry, a is equal to 1 and b equal to 0. I'll just write that. A is equal to 1, b equal to 0. And okay, in equal to 0. Next line out is equal to NB is equal to 1. Next, and A equal to NA, A is equal to NA. How much was NA? Which I think this one was NA. So NA will be equal to 0. Okay, is it? Yeah. B is equal to B. What is B? Uh, 1 minute. Okay, 1 minute. B is equal to 0, yes. And then out is equal to 3. We're passing through AND gate. 0 into 0 is 1. 0. Sorry. Next B is equal to A. 1. B is equal to NB. What is NB? NB is 1. And out is equal to D. So out will be the AND. 1 into 1 is 1. Next. OR gate A is equal to C. What is C here, guys? 1 minute. Okay, just a minute. Okay, I'll just mention this as C and the other one is B. Fine. Now A is equal to C, A is equal to 0, B is equal to B, 1, and out is equal to out. We are passing it through OR gate. 0 plus 1 is 1. So we are getting as the output is 1. So this one. So this is the coding basically.
I don't know whether you guys could. I think you guys were hearing me because I just realized that my earphones was not pinned in. It's okay. Next, we'll go to 1 minute. Will load. Now we'll go with mux. Mux is basically a combinational circuit where we give any number of inputs, you get one output only. Any inputs, but in mux we have select lines concept. Like if you have two inputs, two inputs, we have one select lines. Okay. If you have four inputs, we have two select lines. I hope you guys are clear about this. Next, we'll do the coding part first. Or should I just explain you the? I think I should load the test script and I first explain in that way and then come to the code. It will be better for you guys. Okay, so we are giving a is equal to 0, b is equal to 0, select line is also equal to 0. I hope you guys can see properly. Yeah, I don't know why this. Oh, one minute, I can't. I don't know why is b set as 1. No problem, guys. I think it's fine. It's working. Basically, it's working. I'll tell you what happens. Uh, so I'll just again load mux again so that I can really. Okay. So I'm putting a is equal to 1, b is equal to 0, and my select line is 0. Fine. I'll evaluate. Why do I get 1? Question. Why do I get 1? Because when you give the select line as 0, it takes the input A only. If you give the select line as 1, what will be your answer? Just check. You'll get 0. If you give 1, it will take B as the input. Whatever input is there in B, it will just display the output. Output will be B when select line is equal to 1. If select line is equal to 0, you get the output as A. So I hope you guys are clear with this. This is basically actually what a mux does. I'll show you one more. 1, 1. I'll give this a 0 so that you guys can differentiate what is happening actually. 0 and evaluate. See, you get 0. A is 0, so you are getting 0. Fine. Now you just load the script. Load the script here and loading the script. See, A is equal to 0, B is equal to 0, select line is 0. So what will you get then output as? Obviously 0 because select line is 0, so A will be only displayed as the output, whatever the value of A is. Next, 1, select line we are doing it as 1. So A is equal to 0, B is equal to 1. What will be the output do you think? Obviously because select line is 0, you'll get the 0. One select line is 1 and B is 1. So see, we are getting output as 1. So there are many cases like this. So I hope I have made it clear to you guys what is what actually. Next we'll go for mux 4x16. 4 by 16. Basically what mux 4 by 16 does. It takes 16-bit, guys. The input is 16-bit input and you get the output. Like recently my teacher is Abdul Kader sir in CAO. He has given me the assignment and he's teaching us this mux only, like the word gets stored and it passes yeah, he's like 16-bit word. Each word is 8-bit long, so there are 8 columns, 128 bytes and bits in total. So yeah, in CAO these are the, like, you get to know what is there behind coding and all. Everything comes secondarily. Primarily, what is there in the section, like behind what is what, you get to know that. And yeah, it's an interesting subject. Yeah, without much delay, I'll just go to the, sorry, did I explain you the mux code? I'm really sorry, guys. I think I did not explain you. Sorry, I had phone call. Sorry, really sorry. Now in mux, I'll just tell you what we are doing. I'll take the notepad. Not in is equal to select. So in is equal to, I'm taking select line as 1. Output is equal to n cell. N cell, I'm doing it as not, so I'll just get the opposite 0. Fine. Now A is equal to A. What are you giving at A? A is equal to 1. B is equal to select. What was select line, guys? 1. Uh, Sorry, 1 minute. 1 minute. I'm really sorry. In is equal to 1, out is equal to n cell, that is equal to 0. Fine. Now I'm doing A is equal to 1, B is equal to n cell. What is n cell? N cell is 0. Out is equal to C. I'm passing it through AND gate, so this will become 0. Next, A is equal to B. What did I take as B? A I have taken as 1, so let's take 1. Everything is 1. A is equal to B. B is equal to select line 1. Out is equal to D. We are performing AND, so we get 1. Next, A is equal to C, 0. You can see that C is equal to 0 before. Uh, then we come to as B is equal to D. I don't know which one is, oh, this one is D. So fine, B is equal to 1. Out is equal to 1 because we are doing OR. So guys, so when A is equal to 1, B is equal to 1, select line is also equal to 1, we get the output is also equal to 1. I hope you guys are clear. Next, we'll go to Mux 4-way 16. I gave you the description before only. We'll directly go to the this thing, text fixture code. I know I'm running out of time. I think I have taken a long time, but it's okay because you guys need to understand. Like, even I took so much of time to understand, and it's very difficult to make understand in online. So yeah, we'll start. We are giving all the values as 0. Select line is also equal to 0. We get the output as 0. Now select line has been set to 1. Set select line is equal to 2. Set the select line 2 is also, we are setting actually. See, select line 2 is equal to 2. Because it's a 4 input, so we need 2 select line basically. Okay. Next. Uh, yeah. Whatever value you get in select, suppose you give select line 2 is equal to 0. So whatever is there in A, you get that as output. The same thing, just the same thing, just same. When you're taking select line as 1, you get the output as B. The same. It's just the same concept. I'll just show you with the normal thing, like manually if I do anything, the same marks. Manually if I change, like let the select line be 0 and I keep it as 0. But others, everything I do is 1. Just to show you the, I get that 0. because A is equal to 0. Now if I change it to 1, sorry, just change 1. This to 0. Okay, I'll change this also to 0 just to show you guys. 0011. How are we getting 0? Any idea? Because we are taking select line is equal to 1. So we get the B as the output. Now if we give select line is equal to 2, is it so? Is wrong. I don't know what, but so that's it with now we'll go with Mux 8 by 16. I'll tell you one thing. Done here. Guys, just the same thing here. We are taking one, two, three, four, five. We are taking 8 inputs and one output. So if you give one here, let's check it out. 1 minute, sorry. You get one. See, anything you give, like if even if you give two here, change it. What is the output? Anything like you give any, like even if you give 0, 1, 2, 3, 4. If you give 7, I'll just show you 7. What will be the output? You'll get 0. Because 7, it will take it as H and you will get a 0. So I hope you guys have understood it. And the same thing I've done here, guys. In the coding also, nothing special I have done. I have taken the input A is equal to A, B is equal to B. Select is equal to select of 0. Like take the select line 0 and check what value I've given. And pass it through mux, like normal mux that we do. That is what the agenda is. Just because it's 8, like 8 inputs max, you have 8 inputs, but the cost remains. Now I will do 1 minute, okay? I just have some error in or 16. I'll check that. 1 minute, guys. Because you can see that line number 31 has no comma or something like that. It shows all 16. Sorry, guys. Taking it as dot. That is what they say that comma or something is missing. So even now, if I save it and load this file, I think now it must work. I don't know. So we are done with all 16. All 16 is basically it again takes, like there are 16 bits and every bit, like A have one input, B has one input, and it checks each bit and it does the operation normally. I'll tell you manually. One. Here I'm taking 1111. Fine. And here I'm taking evaluate. What do I get? It just adds it out. Guys, it's just addition, normal addition that you do know. Like even if you take 12 or something like that, and 13. If you evaluate it normally, I'll just tell you, if I load in on 16, I'll execute A0, B0, you get the output as 0. A is equal to 0, B is equal to 1. Sorry, minus 1, you get the output as minus 1. 1, minus 1, minus 1, minus 1. It just checks each bit. Basically, all 16 does that only. 16 plus 16, you'll get a 32-bit number. Basically that, nothing else. Not confusing at all, guys. It just converts into binary and checks each number. You like if 1 and 1 is 1, it normally converts your decimal number to binary and then it performs normal OR operation. Nothing else. Next is I'll do is that, and that value is converted again to binary. Basically that. Next we'll go to demarks. I think I'm taking a lot of time. I don't know why, because I'm doing manually and then I'm doing the test fixture wala thingy also. So it is taking a lot of time. Sorry, this is demark. What does Gmarks does? It is opposite of marks. Like you give two inputs, four inputs, eight inputs, any number of inputs, you get one output. Here, it's just the opposite, guys. It's just the opposite. Like you get many outputs, but there is only one input. So if you get input zero and out select line, you take it as zero, you'll get one. A1, B0. If you get select line 1, I'm sure you'll get B as 1 and A as 0. Okay? It's just the opposite. Like if you give 1 and here 0, select line 0 means A will get the input value. Like the output of A will get the input value. And if select line is 1, you get the B output. So this is the main agenda of it. Yeah, I'll just show this. It's normal. Here what I have done is I'll show you. Yes. Yeah. Dmarks, guys. Dmarks in is equal to select line 1 I'm taking. Out is equal to ncel, that is equal to not, that becomes 0. A is equal to in I'm taking as 1. B is equal to ncel 0. You do AND operation, so you get 0 again. And that is equal to A. A is equal to again 1 is 1, right? B is equal to select line. Select line, what is select line? SEL. What did I take select line as? I haven't taken 1, so I'll take 1 as out is equal to B, that is equal to and 1 into 1 is 1. So you get 1. Did you guys understand? Like basically you're taking select line as 1 and the input to B you have given is 1. So you get the output as B, that is also equal to 1. So yes. Next we will go with Dmarks 4 way. Dmarks 4 way, then Dmarks 8 way, then we'll be done with all the codes of this thing. Project 1. Here I'll tell you what I have done. Basically, there is only one input and there are four output. So you need two select lines. So that is why the you see cell of two, that means two, like one and two. There are two select lines. So if you give one, suppose you give one, and the select line you select it as two. 0, 1, 2. So you get this C. This is normal, guys. This is the most easiest one. I showed you, and I'll just show you one more so that you don't get. Uh, I won't go through again with the text fixture and all. You'll get the same answer. Just the same thing. Just the same. Whatever is the input, whatever you give the select line, it shows output. Now, in is equal to in, select line is equal to select of 1. First, select the line. And then A is equal to A naught. Like basically, whatever I've shown you in Dmux, it just sends there only. The whatever input you have given, it sends there, and whatever select line you have given, on that basis you get the output. Next, we'll go to Dmux 8-way. In Dmux 8-way, guys, there are 8 as usual. And yeah, again the same thing. You just send it to Dmux normal in the program. If you see, you just send whatever is the input, whatever is the select line. You just send through send through the normal Dmux, and you get the answer because that is what actually is happening. Like if I give input as one, sorry, and out select line is six, you I should get the output in G as one. It just happened. Come on, 1 minute. Yes, see, G is equal to one. You guys are fine with it. Like I'll be uploading this. I am uploading this video on YouTube. If you guys have any doubts or something like that, you can always comment, and I'll try to definitely. Yes, I'll definitely try my best to resolve your doubts, solve your doubts. Next, we'll go to NAND2TETRIS folder. We'll do the second project. In second project, we are supposed to do only full adder, half adder, and incremented 16 because our teacher has told us to do this many. So I have to do only this many, guys. And if you want more, I can post a normal separate video, and there I can explain you what is what. Next, we'll go with half adder. I'll explain you the code. Here, XOR A is equal to A. I'll take A is equal to 1, B is equal to 0. So if you do that, out is equal to sum is equal to, if you send it through XOR, you get 1, isn't it? A is equal to 1. Again, B is equal to 0. You get out is equal to carry. You send it through AND gate. 1 into 0 is 0, guys. Next is, yeah. So basically, 1 plus 0 is 1. And carry is how much? 0, obviously. Yeah. So this is how it works. I'll I don't know what did I do. Yeah. Next is I'll load the text fixture code, testing code. Let's see. 00, guys, in half adder you just do normal addition, nothing else. 0 plus 1, 1. You get no carry, right? 1 plus 0, 1, no carry. 1 plus 1, what is the answer? 10, right? So sum you get 0 and carry is 1. So this is what. Do you want me to show you like the next part also? Like we have done A is equal to 1. We have taken B is equal to 1. I'll show you that. Out is equal to sum equal to, you're sending it through XOR, so you get 0. Fine. Sum is equal to 0. Now carry. A is equal to 1. B is equal to 1. Sorry. And out is equal to carry, and you send it through AND gate, so you get 1. Is it verified? I guess yes. So you guys have got the answer. That is correct. Next, we'll go to full adder. In full adder, guys, I have written the code. I have used 2 half adders and 1 OR gate. If you know the logic diagram of full adder, you use 2 half adders, and whatever is the output of the 2 half adders, you just OR it out. Isn't it? Yes, you just do that. I'm just telling you guys. You do that. See, A is equal to A, B is equal to B, sum EB. You just need to sum. I'll show you the full adder, this thing. I think I should load the test sheet directly. Yep. 0 0 0 0, you get 0 0. Next, set C is equal to 1, set B1, set C is 0, and you get the output. Just check 0 plus 1, 1. 1 plus 0, 1. Next, 0 plus 1, 1. 1 plus 1, 0. Carry 1. So you're getting the right answer, guys. Just check. Okay, I'll just check this. Like, if I give 1 1 1, oh, I can't do this. I need to again load full adder and then only I can compute basically. 1 1 mm, 1. If you evaluate it, what do you get? 1 plus 1, 0. 0 plus 1, 1. 1 minute, 1 minute. This hasn't got. Huh. Sum is 1, carry is 1. So that means it's correct. Here, what do you do? Half adder A is equal to A, B is equal to B. Or I just told you, just follow the diagram. In logic diagram, what do you guys do? Like we have XOR gate and we do AND gate to get a half adder. So that is one half adder we use. And then again we use another half adder, and whatever is the output of it, we OR it so that we get a full adder. This is the basically agenda, the main concept. Next we'll go to increment 16. In increment 16, guys, what do we do is that we just increment whatever the value is, we just increment the value. Just see, a is equal to n, b of 0. Just check the least bit, 0th bit. If it is true, you know what is true, right? 1 is true, 0 is false. If it is true, you just equal out, like add it, normal. Suppose you got 0, okay? I don't know why did this. I don't know, it's not working. Some problem must have. 1 minute, I'll just increment normal. Okay, let's start. 0, you get the output as 0. 1, like increment is equal to 1 minus 1. I am really sorry, guys. I don't know why this increment isn't working. 1 minute, no problem. I'll just load it again. Increment 16. Is it increment 16 I'm doing? Or I'm doing add 16? I really don't know. Wait, just a minute, guys. Yes. Okay. Comparison failure. 1 minute. Oh, why am I getting this error, guys? Just a minute. Why do I get such error? Do you have any idea why do I get such error? Because I haven't done the, I did not do the code of add 16, and I have used add 16 as the, you know, I gave it as a prerequisite. So I need to do the add 16 code. Just do that code. 1 minute, guys. Just give me 2 seconds so that I can just do it and finish it off. Add 16, go to project 2, 2 minutes. Where is add 16? Oh god. Hmm. So here basically, yeah, I need to code it. I'll just do one thing. And I don't know what is wrong. Yeah, I'll stop presenting. Okay, guys, as you know that I did not do that thing. Like, I did not do the code of and 16, but I should do that code, otherwise it's not going to work it out. So I need to compile the whole code and then use it in the normal increment 16. I did not see that because my teacher have told that you need to do the normal thing, and I used normally, like, oh, this one, so I know. Let's do this code. It's so fun. But I haven't completed the code of that, and I've directly done that. So sorry, guys. I'll do one thing. I'll, yeah, I had the code ready basically, but I don't know why it did not get saved or something. I'll start presenting again. I'm so sorry for the interrupt. Yeah, share it to you guys. Yeah, I hope you guys can see my screen. Is it so? Yeah, you guys can see my screen. I'll go to this. One minute, 1 minute. I don't know what is happening. Yeah, if I load the chip, and if I load the test script of increment 16, I hope this should work now. Let's check it out. Guys, I'm getting the right answer. Like whatever the value is, it just gets incremented. Whatever the value is, like whatever input you give. I'll just do it again so that you guys can. Okay, 0, 1. Output, whatever you get. What do you get as an output? You get 2. Like whatever you give, 9. Just gets incremented by 1. So that's it from my side, I think. I hope you guys have understood. I just want that you guys should understand whatever I have done it. I'll stop presenting. Yeah. So that was from my side. I hope you guys have understood all the gets and whatever the codes are already available. The codes are already available. So you just need to do the codes and you need to understand whatever code you're doing, even if you're doing anything. All the codes are available in the internet from before. He just said that understand the code so that you can upload the video and you make others understand. So yeah, I think I have learned a lot from this digital assignment because I got to know all the portions of NAND2TETRIS, like how to code, the concepts behind all the codes. And yes, I've shown you the outputs of every other codes. I hope you guys enjoyed it. I'm sorry I took a long time, I think, but yes, if you explain each and every step, I went through all the case almost. It takes a lot of time. So yes, I am finishing my digital assignment here. Thank you. Have a good day. Bye.